refreshed from the nice evening we had yesterday. I'd like to make a small change in the program, and before Dr. Maksudi is giving his promising talk about HANA remote sensing, Shams, who was not able to give his presentation before, will share with you how this, I don't want to use your job, some disaster data can be evaluated using big data analysis, using NoSQL and Hadoop ecosystem, but keep it short.
Good morning everyone, and today I will begin my presentation, and I will explain about big data analytics in my presentation. This is basically research of my master thesis. And in this presentation, first I will make some introductory talks, and then I will explain databases, both NoSQL databases and also big data analytics, Hadoop. And also I will show you how you can analyze data in both Hadoop and MongoDB platforms. Just think about what is going on today and how data is being generated by years. Like in the past, data was only generated by the operators. So only the officials can produce the data. But nowadays, general people engage themselves in producing data. When general people are producing that data, it is quite complicated to make this data in a same schema. And also nowadays we have there are different machines which produce data a lot, like satellite, street cameras. When machines are producing data, then it is quite impossible to handle this data in a traditional platforms. So now, what is big data? Like the concept of big data comes from 2001, and it is the word is used by Rennie, and he determined three parameters for big data: volume, velocity, and variety. So volume means the volume of data will be very big. The velocity means the flow of data will be huge. And variety means there are a lot of variety of data, so data can be come in different formats. But now it's 2017, and we have two more parameters for big data. One is variability and complexity. Variability means you have different flows of data in different times, like you have a peak time, you have a off-peak time for data flow. And complexity means the cleanliness and parsing, converting data into different format is very complex nowadays. So, with this background in mind, I have fixed my objective to analyze and performance of analyze the inbuilt features of NoSQL databases and Hadoop, which are two main big data analytics. And also I will show you how you can manage and handle and wrangle big data in these big data platforms. Why we use NoSQL databases? There are some difference between our traditional database and NoSQL database. In NoSQL database is completely schemaless. There are no tables, there are no relation among the tables. And it can promote horizontal scalability, and it will it ensures the safety of data by replication, and so on and so on. So I can show you some pictorial difference between these two databases. Like tabular databases, there are a lot of tables. There are foreign keys, primary keys, joins, and etc. But when there are a lot of data, there will be a lot of tables, right? And there will be a lot of joins. So in the end, if you just want to fetch one information out of these huge tables, it will take time. So to solve this problem, we have NoSQL databases where you can put all of this information in a single document. Like here, the curly brace is one document, and it holds all the information for a single person, not on the tables. But there are a lot of SQL and NoSQL databases in the market, but which one is best for you? This question is solved by CapTheorem. In CapTheorem, we have three parameters like availability, consistency, and partition tolerance. You will make sure which two parameters you want to have in your application. You cannot have three parameters in your application. If you need availability and consistency, you should use SQL databases. And if you need only consistency and partition tolerance, you should go for MongoDB. And there are other NoSQL databases as well in the market. So now let's talk about data collection. It is quite difficult to download huge amount of free data. So, but there are some platforms like Twitter. It's a good platform for downloading data. It has two APIs, and by using 2AP Python library, it is possible to download Twitter data in both JSON and CSV format. And I have managed to download like 79 gigabytes of tweets, and I download these tweets relating to the US election 2016, which is maybe a man-made disaster. So, okay. So all the tweets I have here are relating to US election 2016. So this is just a view of tweet. What you can see in Twitter. You can see the text, you can see who is tweeting, and you can see the link he is sharing. There is nothing else to see here. But this one single tweet can save a lot of information in the database. Like this is how it looks in the database for a single tweet. We have a lot of information about user. We have a lot of information about tweet generation. We have a lot of information about user location. This is created by only single tweet. And we have here for this research, I have used almost over 15 millions of tweets. So we have 15 millions of this type of JSON documents in the database, which is kept in a MongoDB server. Okay. Now there are a lot of types of NoSQL databases in the market, but which one is best? And the best one I should use in my research, right? So picking the best one is not is a matter of decision. So DB Engines is a website which use a lot of parameters in order to rank the databases, and in their ranking, MongoDB tops the position. Like it scores, MongoDB's score is over 300, and the second one is CouchDB, which scores maybe 30 or 35 or something. So I have used MongoDB in my research. First of all, I want to let you know two major features of MongoDB which you should use for data analysis. Like MongoDB indexing, you should index the field which you use most in your research or analysis. Like I have made a small query here. I just want to get all the tweets which are retweeted exactly or more than 100 times. So without indexing, it takes almost an hour to get the information. But when you use indexing, it takes only 100 seconds. So it is the power of indexing in MongoDB. And there is a major feature for data analysis, which is the aggregation framework. You can use data pipeline in order to analyze data. I will show you later. And it also gives you a handful number of useful operators. And these operators are something relating to SQL databases. So those people who came from SQL platforms can easily cope with MongoDBs. And now I will show you how to analyze the data in MongoDB. Like here are the boxes here. I just to let you know, these boxes maybe represent one tweet, one document, and there are a lot of information on top, a lot of information in bottom. And there is one field called lang, which involves information about the language. So the first tweet may be written in German language, second and third one is written in English language. So I just want to know how many tweets are generating in different languages. So how can I do that? Like first I will use group operator. So group operator will group the same languages and also count the number of tweets. So in the end, I have two tweets for language. So this field will be created, and also I have one for German. And after that, I can use sort operator, which will sort of the results. So after that, I can know how many languages are written in all of the tweets. So I have found that almost 90% of tweets are written in English language and 3% are in Spanish language. And this is the result from over 15 million of tweets which are relating to US election. And now I want to distribute those tweets according to dates. So in which dates, how many tweets are generated. In order to do that, there is only one field which holds this date and time information. Like here, the created at field. Here we have Monday, November 14, and the specific time, the fraction of time here, and also the year. So if I want to just extract the date feature, so we need to parse this field and make a new field like November here should become 11, 10 should become here, and 2016. So I have created a new field in the database, and this field is created over all 15 million of tweets. After that, I have used group operation for this newly created field. Then a project operation will just show you the result the way you want. Like here, this ID you don't like that, so you can change it to date by using project operator. And now sort operator will sort up the result. And I have in the database I have a lot of tweets in November, a lot of tweets in January and February, but I do not have any tweets in December. This is not Twitter's fault or not like that. I did not download data in this time. So, okay, now next I want to analyze the tweets generation in a time of a day. So the distribution of tweets in a day. In order to do that, I have also used this created at field and parse this date time values, which is hour, and I use group operation and other pipelines. And in the end, I found that in the evening, from 5 p.m. to 6 p.m., most of the tweets of a day is generated. And as you can see, we have a peak hour, we have an off-peak hour of tweet generation, and which is one parameter for big data. Now I want to know which are the popular hashtags. Hashtag means you have all Twitter account. Okay. So hashtag means you can hashtag some words, and one tweet can hold a lot of hashtags like this one. And hashtag the text of hashtags are kept in a nested environment. And also here one tweet can have a lot of hashtags. So you cannot use directly group operator here. First, MongoDB has one special operator for this, which is unwind. Unwind operator will expand this tweet. Like we have 3 hashtags here: Hillary, Trump, President. So unwind operator will just make 3 new documents for this document, keeping all the other information same. So these documents have only one hashtag. First, we use match operator to eliminate those tweets which does not have hashtag. Then unwind, then we use group operator and project and sort to finish our result. Then I have found the Oman's March hashtag was the most used hashtag in my database because I have a lot of data like in January, and Oman's March is one big event in US in the time of January. Okay. Now I want to know the person whose tweet is retweeted heavily in order to find out the most popular person in the Twitter. This is a field of retweet. Suppose Siddiq gets a tweet and I retweeted his tweet. So for my retweet, it's create a document, right? So here this user is Siddiq because this is under retweeted status field, and this is me. This is information about me because I retweeted. So I've used this pipeline for this, and I have found the posts of Hillary Clinton was retweeted most, over 25,000 times. On the other hand, Trump's posted are retweeted like 28,000 times. Okay, so I need to find one relation, if there is any relation between his followers and retweeted amount. Here Hillary Clinton's posts are retweeted most, but he has only 10 million followers over. On the other hand, Donald Trump's posts are retweeted less, but he has almost twice the followers of Hillary Clinton. So I found actually no relation between these two parameters. And also CNN have the most followers. So next is the who is mentioned in the tweets. So who is the person who tagged most in the tweets? I found Donald Trump was tagged most in the tweets, which I have in my database, and then CNN first. Okay. And now I want to know from which places tweets are generated. Like it is generated from city area or rural area, and I have found in a rural area we have only 3% of tweets, and in city area we have almost 81% of tweets. And I wanted to know how world reacted in Twitter about US election. So as far as I know, Donald Trump's inauguration was 20th January. So I just want to know how many countries have tweeted before his inauguration and after his inauguration. And I have found in both cases United States tops the position, but Germany was the second position, most tweeted as the most tweeted country before inauguration of Donald Trump. But after inauguration, maybe Germany lost its interest about this election, and United Kingdom becomes the second position about for the most tweeted country about US election. And now I have performed a text search. Here I wanted to know the exact location of the user who used the word Trump in their tweet. So if anyone used Trump in their tweet, I wanted to know their longitude and latitude position. So these are their positions, and there are a lot of people using this word in Europe and also in US. Now I wanted to know user location inside US who tweeted at least where we have at least 2,000 users. But what I found that the states like New York, California, Los Angeles, Washington, Texas, these are the most tweeted states. And as you know, these are the states of Hillary Clinton, right? And these are the states of Donald Trump. But as you can see, there are no tweets coming from this region. So the followers of him may not active in social media. Maybe this is the reason why all the posts gives wrong information before election. Okay, now I want to share you two more features about MongoDB, which is replication and sharding. In my platform, I have used MongoDB in a localhost, but I have used in 3 shards. In 3 shards, you can replicate data in 3 times. These are replication. This is 1 shard. The shards are connected with MongoS, which is the router, and all of these things are connected with config server, which holds the information about the data, where you can find your data in which shard and in which machine. So this is my system. As I used a single machine, so I have I give all the replica set in different ports. Also on the config server in different ports, and this is my MongoS router. And so this is the end of data analysis in MongoDB. I want to say something about Hadoop, which is the okay. Okay, so here I want to just let you know the two most core platforms in Hadoop, which is HDFS and MapReduce. But I will not go detail in this thing. I will just make it short. Like in MapReduce, in Hadoop you can analyze data in MapReduce. MapReduce is two different code like mapper and reducer. Here I wanted to know how many tweets are coming from different countries. So maybe these are the tweets. A mapper code what will do that extract this your country name from this tweet and give a space and the one here. Then Hadoop will automatically shuffle and sort the results of mapper, and then we have reducer code. This reducer code will just sum up the result ones for a single country. So in the end of performing all 15 millions of tweets, we have the final result. This is the comparative analysis for MongoDB and Hadoop. For a single machine, but it is I want to show you that this is the result of single machine. For a single machine, MongoDB performs well for data analysis, although it is not comparable because Hadoop is basically created for a distributed system. So I don't want to argue with anyone. So this is only the result for a single machine, and yeah. So I'm almost done. Like you can find a lot of hidden features in big data. So and also there are a lot of developers nowadays. Like in our platform too, there are a lot of developers. So we should think before we developing like how many users we will have in the future. Like before Facebook was built, like it was built for a community, like for 10 or 20 people. But now it is using the whole world. So before using or developing your application, think better that maybe one day it will be popular and many people will use it. So, thank you.
Thank you very much, Shams, for your rush and for being in time. Nevertheless, I found it interesting. And at least one question. Go ahead. Rafael, please.
More than a question is like a comment. From my personal experience, we have to think or to make a very good analysis before to migrate into a Mongo or not SQL database, such as Mongo or MongoDB, because these databases are built in order to store a big amount of data. But if you need some relationship with the tables, it will be very difficult to do it, a simple join. So before to create a NoSQL database, is it better to assess if an SQL database will do the same? That is only a comment.
Because you have to do a lot of data modeling before making your application. Of course, you are right. Like you do not need to use NoSQL databases for your application. Sometimes SQL databases, many times SQL databases is better. But if you have a bigger amount of data in your application, maybe you should check if it's better or not. But you have to do a lot of data modeling before you putting data in your server.
Thank you. Very briefly. Yes, Dennis, please. Since Ashik Patel and then it's over.
Yes, very good. So you work with already tweeted posts, but will it be possible also to work with live tweets?
Sorry.
Will it be possible to work with live tweets?
Live tweets?
Yes.
No, you can download tweets like 7 days back. So live tweets means I don't know what you mean, but
No,
it's
just
now.
it was just posted.
yes. But
So,
no, you can access to the live tweets, and you can download from this time from 7 days back freely, but not before.
Quick question. One of your slides you showed that it takes 100 seconds for a query to the MongoDB from a 15 million.
Yes.
Is it because of your system or is 100 seconds is standard? Can we?
No. This is
still a bit more.
you will use like one database for in order order to extract one information out of the data, right? In your application, what will it do? It will send a request and it will get only one row or only one application. But in this request, or like in this query, it have to look for all the documents. So it will take time. Both in SQL and MongoDB, it doesn't matter, but it will take time. But in SQL, it may not be possible. Like it will take huge amount of time. It has to go through all the rows and all the tables, right? But what indexing will do, through indexing, it will only look for those documents which have your information. Like I cannot find it over here. In here, indexing is only scanned 13,000 documents.
Yes,
Yeah.
I got it, but in my opinion, 108 seconds is still a lot of time.
Yeah, it's still a lot of time, but it is doing scans for all the documents. It is not going through all the documents, not only one information. It is
On his machine.
It's
just we have to compare.
Anyway,
It's just a relative measurement.
Yeah, maybe you use a distributed system, it will perform well, but it is only a single machine.